You hear me okay? Yeah, apparently. If I seem nervous, it's because I am, but that's okay. We'll get through that. I'm Hannes. Today we're going to talk about building flexible software. We're going to start with two disclaimers. First one, please put down your pitchforks. I know that I disrespected Lego in the title of my talk, and I should never do that with developers. Because you're all probably like me. You grew up on Lego, you're feeding Lego to your kids, and you curse that you did that whenever you step on a brick, right? This is a set that I dreamt about as a kid. It's the control center. It was awesome. But marble tracks are awesome too. My kids built them all the time. And I didn't want to hold out this picture from you guys. They built this actually a week before I first gave this talk. And they had used Duplo, which is a Lego product, to build supports for their marble track. I didn't encourage them to do this in any way, but it happened, and yeah, I felt it belonged in the presentation. Second, I'm not going to be talking about any hipster frameworks or fancy libraries. All this talk is going to be about is about how to structure your code to build a flexible product. So if you came to the wrong talk, that's okay. You can walk out. There's another slide after this that you can use to leave the room. So that's what we're going to do today. Now, I felt that I had to put this in. You shouldn't be saying Legos, right? Lego is a brand name. You use it as an adjective. You say something like Lego set, Lego brick. You never say Legos. It will trigger Lego people. Right. Down to the business of the day. I first have to tell you a little bit what our situation was when we built the proof of concept that led to this talk. We were working in a company that built a huge IoT platform. I'm talking about smart metering, thermostats, smart plugs that you can put in the outlets of your walls, all that sort of stuff. Window blinds that you can control, basically a whole smart home. And what we did is we had a huge backend that allowed to collect data from all those devices and to push control to them. If you want to change the set point of your thermostat, you send a control message to the IoT device. And we had a core that had all the shared functionality. And then we had a lot of implementations because we were supporting new devices all the time because the company that I worked for was an integrator. And they integrated with all these external suppliers of devices. And usually we did the implementation during the contract negotiation phases. So our company was talking to the suppliers and see if we could work together. And then we would basically integrate their device into our core to prove that it works, and sometimes it would make it to a contract and we would start working with them, but a lot of times it didn't. Now all these devices, they had these extended properties, and we would deploy only one platform, right? We had this one central platform that we would use for all our customers. It was a huge multi-tenant thing. Now these new implementations, as I said, they arrived all the time. And you know how it goes with product managers. They ask you to do something, has to be ready pretty quickly because the deadline is already overdue. So you do the implementation, and they tell you, no, we'll have time to rewrite it later. And then it was worse than that. It didn't get rewritten, but the customer never signed, and the code couldn't get thrown out. Because they had this impression that they had already invested money in this code and they could never part with it. Sound familiar? Yeah? Right. I'm not the only one. I think we run into that all the time. So we had this huge maintenance hell because we had a lot of code that was written rather quickly because the deadline was overdue. And we couldn't throw it out of our code base, and it was all pretty tightly coupled. So it wasn't really a good place to be. And this is a quote from Ken Thompson. I'm sure a lot of you have heard it before. It's like the most productive day that he had was when he threw away 1,000 lines of code. And that's how I felt at that customer. And my sons, they would disagree, because my oldest son, his favorite color is green, and the second one, he has a favorite color, yellow, and I found these two pretty suitable because they're built out of Lego. But you have to be able to take a wrecking ball to your code. Because everything that you don't use anymore is just sitting in the way. Every time you refactor, you're actually touching that code again, maintaining it, making it work with the new improvements of your core. And you don't want to do that for code that's not delivering any value. If you don't have any of those devices running on your core platform in production, why would you even support that code and keep working on that and keep investing money in it? So we wanted to change that. We wanted to improve things for ourselves. But our product management wasn't ready to change. They almost flat out told us, like, yeah, it's going to be like this forever. So the new implementations would keep coming, the new devices would keep streaming in, and a lot of them would never actually be used in production, but they wanted to keep the code. Now we got them to the point where if we could resurrect the code and take it out of the deployment, that was fine for them. So that's the win that we had. So what we wanted as a development team is we wanted to be able to do these new implementations really quickly. Because we knew that they came all the time, and that it was usually under time pressure, so we needed a way to actually do that quickly, and then to be able to remove it from the code base really easily. Because if we could remove it from our deployment, it wasn't sitting in the way, we didn't need to refactor it, and so on. But that meant that we needed a lot less dependencies and a lot cleaner abstractions in the code base that we already have. So I think a lot of you are already thinking, how do you solve this? You use microservices, right? I'm going to park that question for a second. Because to understand why we did what we did, you have to a little bit transform yourself into the journey of a junior object-oriented programmer who goes on his journey through life. We all learn by doing things. And if I look back at my code from last year, I wrote some pretty terrible stuff. And I'm pretty sure that future me will think the same about present me. I hope, at least, because that means that I will have learned something. But we all grow. I mean, I think we can all look back at our code base from years ago and feel good about ourselves because we have grown. And the code that we write today is a lot better than the code that we wrote years ago. The thing is, when I talk to other developers, I feel that a lot of people have gone through the same journey. And that journey starts with something like this, a big ball of mud. You start with taking some demos from blog posts or Pluralsight videos or whatever, and you throw it together into something that works. And you start building on top of that, and you drag in new stuff, and it becomes a huge, complex mess, right? And at the moment, you will run into your own limitations, because at some point, you can no longer support this. You can no longer keep growing. And hopefully, that's the point where you learn that you cannot continue doing this. Hopefully, this happens in university. You don't do this in a customer project, but everybody starts somewhere, right? And you learn. So the first thing you start doing after that is you start building layers. You think about grouping all your code into logical units. You think about your UI being at the top and your database being at the bottom. And in between, you will have services, you will have business logic, and so on. Optionally, you can deploy them separately and treat them as tiers. But the problem with this is the first time you do it, it will still be all very tightly coupled still. And you only want your layer to consume the layer below it. That's not what you do with cake, because that cake is yummy, you will consume it all at once. But your layers just consume the layer below it. But you notice that your layers become bigger, and you notice that if you want to change a feature or remove a feature or whatever, you still have to touch all the layers because it's vertically integrated, and it's still not really flexible because it's still pretty tightly coupled. So you learn, and you learn about solid, and you start doing solid. And you read about the principles, and you start applying them, and it all seems very good because you have these small classes that do only one thing, and it becomes easy to do. But what you see is if you have a team with maybe some junior developers, that you will basically apply all these patterns at the same time for every feature. So you basically will build layers in Solid. You build abstractions over abstractions over abstractions. And I've seen more than one code base that did this, so I'm pretty sure that it happens all over the place. And the thing is, if you do this, you will end up with a code base that's full of single-line calls to the next abstraction. You will still have layers. Everything will still be coupled. And it doesn't really work for you, because all those single-line calls, they don't do anything except add refactor friction. And hopefully that's when you learn. At some point, it will click for you. And for me, it clicked when I made the realization that an interface should be owned by the consumer. And that's the point where, for me, and I know other people have other experience, but that's fine, at some point it will click and you will understand what Solid is really about. And then you start actually building flexible code. And this is the point where it becomes easy to write unit tests, and it becomes easy to even do test-driven design. And my preferred way of doing Solid into a .NET code base is using Onion architecture. I'll get back to Onion architecture in a minute. So that's basically what solid code should be about. It shouldn't be solid at all. It shouldn't be anything like a Lego castle. It should be more fluid. It should be like a bag of marbles. I could get two guys from the audience, but I think we all know what's going to happen if I ask you to replace the middle tower with the white one, and if I ask somebody else to replace the blue marbles with the green ones. It's going to be a lot easier to do the marbles, because I constructed that castle in a way, I'm an asshole, I constructed it in a way that if you want to take out the middle tower, you will actually have to deconstruct the two outer ones as well. You're fucked. So we're not going to do that contest, but that's what a lot of our code looks like. It looks like that castle. It's all very tightly coupled together, and it's very hard to remove stuff. And basically what we want is the marbles. And only after you get all that right, I think that you should be getting into complexing your life further by doing different deployment models. I think you should learn to do everything right in a monolith first, and then grow into more complex deployments. Because if you have more units of deployment, it complicates your life in so many other ways. Monitoring becomes harder, debugging becomes harder, and so on. And I feel that at the moment is the fancy thing to do is to start with microservices right away. And a lot of teams, they don't realize they're adding a lot of friction to their development and deployment process where they really shouldn't. Because if your website has like 50 concurrent users, you can just have like a small instance on Azure and deploy it to that, and you'll be fine. And it will be easy to debug and easy to monitor and easy to deploy. So I'm going to paraphrase Martin Fowler a little bit. He said that the first rule of distributed software is don't distribute. I changed the quote a little bit to fit Fight Club because it's an awesome movie. But he is right here. You shouldn't complicate your life until it is time, until you really need that. There are a couple of reasons why if a team or a product grow to a certain point, you will always end up with microservices. And that's fine, but you shouldn't start out doing them unless you have a really, really, really good reason to. So our code base was a bit around step 3. I think our code base looked most like this. We had lots of abstractions with single-line calls. And it was already multiple units of deployment, and we didn't really have a need to further distribute, so microservices wouldn't really help us because our team was quite junior. So we weren't ready, to be honest. And my take on this is that you should not solve your code problems with deployment problems. You should never do that. Because we programmers, we feel at home when we're writing code. If you're writing code, you know what you're doing, you know what the effects of what you're doing will be. But if you're setting up deployment pipelines and production monitoring and all that kind of stuff, you go a little bit out of your comfort zone. I don't know how it is for you guys, but I feel more at home in Visual Studio than I will do in Azure DevOps. So we decided not to do microservices at all, and we decided to aim for plugins. Now, what were the challenges that we were facing in our product? The front end of our application was actually an API, but for me that's as front end as it gets. I can only touch JavaScript with a 10-foot pole. But the front end of our application was an API. And we wanted to be able to extend all our core API calls with the new derived types. That meant that it's very easy to add, as I'll show you in a bit, to add extra controllers to a running ASP.NET application from other DLLs. It became a lot easier with Core 2. But if you want to extend these central calls, it's like get all devices for customer or whatever, yeah, you would get those derived types with all the correct properties. So you need to extend those central cores with outside logic. That was actually the biggest problem we had, because we had to go all the way to our entity framework DB context with the extension. We wanted to extend the logic, and we wanted to be able to handle all the migrations for our database, which is always a tricky thing to do as well. So one of our developers told me that entity framework cannot do this, and we will hit a wall, and that's not possible, and it's the best way to get me to do anything. Tell me that it's not possible. Because I will find a way, I will work through the night to figure out how I can prove that guy wrong. So we did that, and we built a successful proof of concept. At the time, it was using Entity Framework 6, and we were using ASP.NET MVC 5. Well, Web API 2, I think. So we adopted that model of doing stuff. And this is where I'm going to actually divert a little bit from reality. Because two things, I cannot use the code from that company to show in my presentation. Second thing is, yeah, we have .NET Core now, which is a lot better, and it makes a lot of this stuff a lot easier. So I wondered, like, how do we do this in .NET Core, and can I show people how to do it? And the first thing that you will need to know to get into our conversation is onion architecture. Onion architecture is a term that was used by Jeffrey Palermo about 10 years ago. But it's not a new concept by any means. It's basically ports and adapters, or hexagon architecture. It's known under all these names. Now, the whole point of this, and that's why it matches so well with Solid, is that you will try to keep your dependencies really clean. It has nothing to do with the onion, by the way. They're not clean at all, but they're really funny. But you want to shield all your abstractions from your core logic. That's the thing that you really want to do, and make your product very testable. And what it looks like is a bit like this. At the center, you have your domain model. It's all your classes that are in your domain. Around that, you will write your domain services, which is basically your business logic. And around that, you will write your application services. That's basically how your core communicates with the outside world. And references can only point in. So you can only put references to the inside and not to the outside. That means that everything else is an integration, even your database. And that's where this differs completely from the layers that I showed you earlier. Because we will not point to our database will point to our core. And all these integrations make sure that you can basically shield anything that might pollute your logic from it. It means your core will be completely reference-free. You will not reference Entity Framework in your core. You will not reference AutoFac or AutoMapper or whatever. Your core, well, I make one exception there. Are there people here who use Node.time? No? Yeah, some at least. Good. If you want a better datetime library than the standard .NET ones, Node.time is awesome. It gives you concrete types for pretty much everything that you ever need a date for. So if you need a local date without a time, they have a type for that, and it's awesome. But that's like all it does. It gives you the types to work with. So that's something I allow in there, because otherwise it would become really hard, but all the rest I keep out of the core. And everything else is an integration. And if you want to talk to a database through Entity Framework, what you will do is you will define an interface for what you need from that database. And you make the implementation in your infrastructure layer. And only there you will know about Entity Framework, and your core stays really clean. So all these things, they become dependencies, but not really in code. They become dependencies through clean abstractions. And this will require a DI container to tie everything together. I know that there are some people who don't like using DI containers, but you won't get away without one for this. So the first thing is you don't get leaky dependencies. Nothing leaks into your core logic. And that is really cool, because for the first time, your dependencies become really replaceable. If you want to use another DI container, you just re-implement the interface that you wrote for the DI container, and you're done. And you don't have to refactor all over the place and replace references and so on. You can actually quite easily replace something. The other thing that you get is that your core is not polluted with any presentation logic, which means that you can throw this core into another UI. Let's say you build a web application and you want to throw it into a desktop application or whatever. You can really easily do that without changing anything to the logic. And this design really forces you to do what I told you earlier. It's like if you consume an interface, you're the owner of the interface. And here you have no other way but to define the interface first and then implement it on the outside. So it forces you in that direction. And with test-driven design, it becomes really clear where you should write which type of tests. Your core is really easily unit testable because it has almost no dependencies. The only dependencies that you have will be other core classes that are injected, and you can really easily mock them. If you write integration tests, you can just write them against your infrastructure layer. And that becomes really easy to do because your infrastructure layer doesn't have any dependencies to the core, so there's nothing to mock. You can just do the integration tests. So that makes this whole thing really nice and easy to do. Now, I do it a little bit differently, but it's just potato-potato kind of stuff. I don't like, if you look at this design, remember your domain services will actually contain most of your business logic. I don't like outside code referencing classes directly. I want them to go through interfaces. So when I structure it, it's basically the same thing. But I structure it like this, and I only reference the contracts and the models. I never reference the logic. But if you look at it like this, the models are actually your domain models. The contracts are your application services, and your logic are your domain services. So I make one more rule than Jeffrey Palermo did. But if you keep your core clean at all costs, and that's the only thing that you really need to guard, it will really help you with a lot of implementations. Let's say that you need some kind of integration. For instance, our DI container. Now, we don't want the DI container to be in the core logic, so we're going to have to define what we want from a DI container. Because if you look at Autofac, I don't know about you guys, but that thing has like 1 million possibilities to use, and you're going to use like 5, right? So you define the few things that you want from your DI container. What I usually want is I want to be able to register my types at runtime. I want to be able to set a scope where they get resolved, so that whenever in my HTTP request I will receive the same DB context, that sort of stuff. And I want to be able to insert my plugins. We'll see that later. So you define what you want, and you make a contract for your DI container. And then you're lazy, because you're a developer. You should write as little code as possible, so you go looking for a NuGet package that does what you want. And you will find something like Autofac or Castle Windsor or whatever. And then you write the implementation, and that one consumes the package, and it fulfills the interface. Because you only define 5 calls, that work should be trivial. If it's not trivial, you pick the wrong NuGet package. That's all there is to say. And what happens then is life becomes peachy. Rainbows, unicorns, you don't have anything that leaks into your core, and all your integrations are easy to write. And you become that developer that sits in the woods. I don't know how he works after 2 or 3 hours when his battery is dead, but he sits in the woods. It gets the image across of the happy developer, but there's so many things wrong with that picture, right? But now we've talked about the core of our application. We built our core using Onion architecture, and now we want to tack plugins on top of this. Remember that we want to do these implementations of all these devices, right? So what did we want from our plugins? They should be easy to develop, and they should extend our core logic seamlessly. That's what we really wanted. And to enable them in a certain deployment, because we did have separate environments and we wanted to demo new devices in the acceptance environment for potential customers, but then not add them to the production deploy until it was really certain that they would go to production. So instead of working with feature flags and polluting your code with that kind of stuff, we figured out if we can just deploy the assemblies and the features enable themselves, that would be like the best thing. And then removing them again was just like we remove the assemblies from the deployment and we're done. That meant that we could not have any references to our plugins because that would make things really, really hard. And we needed to make more rules because, yeah, that was too easy. So, no, the plugins could reference the core. And we wanted them to follow some conventions because, yeah, all the plugins should be alike and it should be easy to for anyone to get into a plugin that they hadn't written themselves. And they should not break anything when we remove them from the deployment. And that was not so trivial, actually. Because what happens is you deploy a plugin, and a new device type pops up. And you connect the device, and at that point, you will have data in your database that came from a plugin. And if you remove the plugin, then your code won't understand where that data come from, and you will have runtime errors. So that's something that we didn't want. Are you still with me at this point? Good. I'm going to show you the bits of code that are interesting that you need to make this work in .NET Core. And it's really not that much code, so hold on for a little minute. I couldn't use the code from the IoT platform, so what we're going to be talking about is a toy collector, and there will be a plugin for Lego and a plugin for marbles. You can check out the code from my GitHub. I'll give you the link at the end if you want to look at it yourself. So that's what we're building, and it will be fairly easy. Now, the first thing that we need to do is to get our DI container wired up. And we cannot just scan all the referenced assemblies, because with Onion architecture, you will always have this point. Because your UI, and your UI is usually your startup project, right? Your web API will be the project that starts up on the server, and that references the core, but the core doesn't reference anything else. So if you scan the referenced assemblies, you won't get everything back. Now, there's two things you can do, but basically, the thing that we always did is you make type registrars. And it's a simple interface that you implement. I'll show you in a second. And what we're going to do is we scan all the assemblies in the deployment folder, and we scan them for these type registrars, and we run those. That's basically all we did. It's not really that hard. Now, the thing is, Visual Studio also doesn't build everything if it's not referenced. So if you're changing something in your whatever integration that is not referenced by your core, and you start up your UI, it won't build that project because it feels that it doesn't need to. So you have to tweak your Visual Studio a little bit, or you do a manual build step. That's also something you can do to copy the assemblies to the executing directory. What you can also do is you can make a development assembly where you do have the reference. It's up to you. One requires like the extra click, like the manual build, and the other one makes your life easier, but then you have to make sure that you have two solutions that you maintain, one for development and one for your build process. Now, these type registrars are really not that hard to do. What I did there is I have an interface for a type registration container. It's basically a wrapper around the service collection of ASP.NET Core. And I will just load all the DLLs, see if there are implementations of the iType registrar in there, and then I will instantiate it using reflection with create instance, and I will run that code. This is not hard to do, but this is your assembly scan at startup from the project. Now, what is already a little bit trickier is ASP.NET Core. ASP.NET Core makes it a lot easier than it was in MVC 5. If you wanted to add runtime controllers to an application, you basically needed to write a custom controller selector and a custom view selector. You can Google it, it's out there. It will take you about a day probably to get it to work properly the way that you want it. But in ASP.NET Core, we have this thing called application parts, and you can register assemblies in runtime to extend your application. So if you need to add new controllers, your work is already done for you. What does this look like? You just, in the startup of your application, you call add assembly part. There are different ones for the views and the controllers, because when you generate a new Razor application, your views get compiled to a new separate view application. Now, the thing is, as I told you, we weren't really doing Razor views. We were doing an API. And with XML, it's really easy. If I want to post a Lego set to a service, that's really going to be easy to do, because I start my XML document with a Lego set tag, and I use all the Lego set properties, and then I will close it with a Lego set tag again, and my deserializer will know what to do, because it has loaded that type into memory, so it can do what it needs to do. With JSON, that's a bit harder, because JSON doesn't have type directives. And if you have a controller that accepts a toy, it will have no way of knowing whether it's a Lego set or a marble or whatever you throw at it. And you have this thing called type name handling. And type name handling gives you this feature. You can basically add the type of what your JSON document is to your JSON. And that's really all fun and games. But I have to warn you, I only learned this a few days ago, and I didn't have time to completely rewrite the code yet. There are other ways of doing this. You can write a custom implementation where you have a type property that you handle yourself, and then you deserialize to the right type. You have to extend your model binder for that, but that's okay. The thing is, this has a security leak in it. And that security leak got up on OWASP. So before you use this, research what the security leak is. You can counter it, but don't just use this out of the box, please. Right. But this gives you in JSON what you need. You can tell your APIs what the types are that you're working with. Now, one of the other things that we needed to do is to extend logic. And extending logic is not really that hard. We can have some interfaces that we define in our core, and we implement them in our plugins, and we register them in the type register. Now, what we need for this is a scoped service locator. The reason that you need a service locator for this is that oftentimes you will know in your central API core, you will only know the type at the moment that you actually get a call. And then you have to resolve a generic interface. Now, the problem with that is you don't only need to have the generic interface, the one at the bottom, you also need a way to call it, to construct it and to call it. So what I usually do is I use the superclass toy in the main interface, and then I will make a generic one that I can implement in my plugins. And the reason to do that is that the superclass will just accept the toy. And if you then go to your ASP.NET controller, what you're actually getting is a toy, right there. And if you would have to cast that to the correct time that you will only know at runtime, it's so much harder to do, and you can just resolve the interface based on the type, because the type will be correct. That one will actually give you Lego set or marble. So if you do that, you use it to resolve the generic interface, and then you just call it with a toy, and you can unbox it in your implementation. It will be a lot easier to do it like this. And then the last thing, the thing that the other developers said that we couldn't do, was to extend Entity Framework. Now, all of you who have worked with Entity Framework will know Entity Framework needs to know about 3 things. It needs a model of your code, your classes. It needs a model of your tables in your database, and it needs a mapping between those 2. And for those of you who have been around long enough since Entity Framework 1 and Entity Framework 4, they will know that we used to keep that data in a file called the EDMX file. It was a huge XML file that would always cause merge problems. There's a reason that we don't have it anymore. But at the moment, in modern versions of Entity Framework, since 4.1, we have this thing called code first, and we derive actually the same information, but we derive it from our code. We will add mapping code, we will add attributes, but most of the information that Entity Framework needs to run come from the code. Now, the fun thing is that Entity Framework doesn't need this code at compile time. You can just feed it all this information at runtime. So if you have a DB context that has a collection of toys, you can tell Entity Framework about Lego sets and about marbles at runtime. That's what on-model creating is for. Now, Entity Framework Core has some features that EF6 had, and it also misses some, and one of them is the different inheritance models. So Entity Framework Core only supports table per hierarchy inheritance. It means that all your fields go into the same table, and you will have some kind of column that you use as a discriminator to tell you what type of record is in there. The problem is that if you remove your plugin again, I remove my marbles plugin from my deployment, and there are rows that have a discriminator that says this is a marble, yeah, you will have runtime errors in EF6. The fun thing is that Entity Framework Core automatically adds a where clause for the discriminators. So it will only query all the discriminators that it knows about. It already assumes that there's going to be data in that table that it does not want to see. And that is a very nice thing. Now, it wasn't really hard to extend EF6 to do the same thing, but you get it for free. Now, how do we extend the DB context? We basically have an interface that allows you to extend the DB context, and there you can basically access the model builder. The reason that I use object there is the same reason as before. I don't want to drag Entity Framework into my core, and to actually name that property DB context would mean that I need a reference to Entity Framework in my core, which I don't want. Now, the only thing that will get passed to this is DB contexts, so is model builders. So you can actually just cast it. It's not really that big of a problem. And that's where you apply new configurations. And there is this generic set function that you can use on a DB context. If you want to have a DB set just for marbles, that's OK. But just adding the mapping for marbles will actually extend your knowledge. Entity Framework will know about not just toys, but also about toys that are Lego sets and that are marbles. And if you register them like this, you can just inject the collection of extensions. And if you inject the collection of extensions, you can basically run all of them at once and tell in the on model creating, and you'll be done. So that works really well. And that means that our API, we had all the things that we wanted to do. We could actually add new controllers. We could add new functionality to existing controllers. We could add new types to all the code that we were already running. And we could extend the logic in all the places that we wanted. The only thing left to do is migrations. And there are basically 2 approaches you can take to migrating a project like this. Who here has worked with Entity Framework migrations? OK, so a fair bit of you know what we're talking about. Now, you can just use Entity Framework migrations for this if you want. And that's actually what we ended up doing. I like the other approach better, so that's why I'm going to talk about both. Now, entity framework migrations can be used if you basically migrate for all the plugins. It means you make a DB context, you load all the plugins into it, and then you base your migrations on that. And then you will have a database that basically always has all of the plugins in there, all of the tables and the fields. Maybe they will not contain data, but it will work. The good thing about this is easier to do deploy time migrations, because you can just take those migrations and put them into your deployment. Now, there is one problem with this, especially in Entity Framework 6. Entity Framework knows about the version history table, the migration history table. Sorry, version history is in the other approach. The migration history table. And actually, it will write a record there with your last migration, and it also has a field that has the model state of your DB context when it was migrated. And Entity Framework will query that table and will check if the model state matches with its internal idea of what the database should look like. And as soon as they don't match, Entity Framework will go like, yeah, I'm not doing this. And that's a real problem. So if you migrate for all the plugins and you only deploy a few, your two models will not match and everything will break. Ask me how I know. But it's really easy. If you do your migrations at deploy time, you can add a step where you actually just rename that table after you're done. Because then the next deployment, you can just rename it back to its original name, run your deployments, and then rename it again. And if Entity Framework doesn't find that table, that's awesome. It will just think that the database is in the correct state. And it will just continue doing its work, whether there are more or less plugins in the database. If a field doesn't exist and it tries to query it, then it will break. Now, the other approach that you can take is you can keep your migrations separated. And I like that idea a lot better, because you can basically have your database migrations in sync with the code that you write. It means that you will write migrations that are necessary for a plugin in each plugin. And that's really cool, but it almost forces you to do runtime migrations, because you will have to see which plugins are there and then see if there are missing migrations and run them. And not everybody likes this, because if you have a DBA, he will not like the idea of your applications changing the schema at runtime. There are some ways around that. You could make a migration runner that takes in the set of plugins that you're planning to deploy and then run that. That's a possibility. Now, the thing with the decentralized ones, and that's the biggest reason that held us back, is that you really have no way of checking if some plugins actually interfere with each other. Say that you create the same field name twice, but it has a different meaning. Yeah, that would mess up if you deploy the two plugins together. So what does it look like? Yeah, the central migrations are actually, I didn't put any code on a slide, because it just, Entity Framework Core takes your startup project in your solution to call the onModel creating and then do the migrations. So if you have all your plugins in the same solution, basically Entity Framework migrations is going to behave the way that you want. So that's all really easy to do. I'm pretty sure that you will figure it out. But remember that you have to rename that table before and after the deploy. Now, Fluent Migrator is a third-party project. It allows you to do migrations that are very similar to Entity Framework Core migrations. But the thing is, they don't care about the model state as much. They just have code for an up and a down step, and that's pretty much it. And they will look like this. Now, the disadvantage is you will have to write this by hand. But it's really not that hard to do. I'm pretty sure that as a developer, you would have not more work doing this when you compare it to opening SQL Server Management Studio. And all these migrations, they have a number. And this migration framework doesn't care if they are all executed in order and if the model state is correct before we start a migration, after it, and whatever. It will just scan the table. It also has a table. It's called version history. It scans the table. It sees which ones are there and which ones it knows about, and it collects a list of missing migrations, and it just executes those in order. But it might be that you redeploy a plugin after a while and you have like 4 missing migrations, but they are all over the place and there have been migrations with higher numbers. No problem whatsoever for a Fluent migrator, which makes it very suitable for the case that we were working on. There's only one caveat. When you make a migration runner for Fluent Migrator, you have this builder pattern, and you can tell it to scan in, and then you can pass it a list of assemblies where it should scan for migrations. Now, with a builder, you would think that you can call that scan in multiple times to add more assemblies. Yeah, this is not true. You can only call that once. The last time that you call it, that list is the one that gets used. So you have to build up your list of assemblies first and then pass it to it, and then it will work as intended. And the result of our project is actually very nice. We had very clean dependencies. We had a core, and it only gets referenced from the outside by our plugins, by our migration projects, by our DI, and even by our UI. The only link that might seem a little bit out of place is the one going from web to DI, but you need to wire up your DI container at startup, right? So, to conclude a little bit, what I'm going to do is I'm going to do the conclusion, then do the frequently asked questions, and then we have a little bit of time for questions, and then I'll have 2 more slides at the end. So the first thing you should always do is structure your code and make your code as flexible as possible. Don't try to introduce new complexities if you don't need them. Plugins and extending entity framework and ASP.NET is really not that hard to do. It used to be a bit harder 2 years ago, but it really isn't today. So it shouldn't really hold you back to try this. Don't solve your code problems with deployment problems. So don't add like 1 million microservices to solve a problem that you didn't find a way to structure your code properly. And if we think about the steps in the beginning, don't worry if you're not at any step yet. You will run into the same walls that we ran into, and you will get there. And I don't know if there's a step 8. I hope there is. I'll tell you when I get there. Now, the questions that I usually have about this, like, isn't this a lot harder to do? And it really isn't. The thing is, you need a bit of setup at the beginning of your project to get everything wired up. But every new project that you start, you're going to have a setup phase. So it doesn't really hold you back that much. Now, somebody else asked me in another time that I gave this talk, like, shouldn't the plugins be onions by themselves? And yes, they should. They really should. But it would complicate the demo too much. But if you're starting to do this on a larger scale, you basically will want your features to have an onion structure inside them. So do that if you ever get into this and start doing it seriously. Now, when should you do this? Well, for onion architecture, I don't see a reason why you shouldn't. It just gives you a lot cleaner dependencies in your code base. It will work for any project in any object-oriented language. Now, plugins, that's a really different scenario. It's very good for when you need modular deployments, like we did. If you, for instance, have deployments that are based on a customer's contract, whether they get certain features, that could be a really good reason to do this. And if you want to be able to easily retire and replace code, for instance, if you do A/B testing, that's really nice. And one of the big advantages that I didn't really talk about is if you make all your plugins have separate build pipelines, it becomes a lot easier on your build servers to build a large solution. So that can also be a reason to do this. And then there is the 10-100 rule. And I don't know if it's called the 10-100 rule. I didn't invent it either. I think Udi de Haan once told me about it. It's basically if you can get your business to agree to write any feature with 10% of the effort. You just do it quick and dirty. but you set a very hard expiration date on the code. And that's why it's very important that your business is on board with this. You write it quick and dirty, you deploy it, you see how it behaves, you see if customers like it, you see if you get a response for it. And if at the expiration date your business people decide we want to keep this feature, they know that they will have to spend 100% of the development time at that point. So you will basically invest 110% to write this feature. But if you like to try a lot of things, you can try 10 times the amount of things if you write them all quick and dirty and then throw them away after. But if you're not allowed to throw away that crappy code, you're gonna hurt yourself really badly. So you have to have your business on board for that. But if you do that, then plugins is a really good model to try that out. Right. Ask me some questions.
Do you see any of your partners creating these plugins instead of your own people?
Do I see any of my partners? I've basically done this at 3 projects already. So it's also a very nice way to, I'm going to repeat the question because not everybody heard this. He asked me if I see any of our partners do the same thing. That's the question, right?
To integrate their technology.
Right. No, on the device side, you mean? Right. No, because they were always focused on this one thing. They did their device with their features, and we basically had to adapt to them. That's why all of our devices look differently in our code, because we had to work with the manufacturer's spec.
Now that you have this architecture, did you communicate it to your client and tell them that you can do that yourself? Created by you?
Yes, at the moment, I'm actually doing something very similar at another project, and it allows you to make any software project really flexible. And we could use it for external development because we did have different teams in that IoT company, and anybody could write a plugin. But we didn't allow our customers to make the plugins for us. That was our responsibility. But you could. It would be a possibility. You can make a very clean API of extension points if you do it like this. And then you can basically review the plugins when they come in and deploy them along. We would make a list of plugins in our deployment pipeline. So we had a simple text file that basically decided which plugins should get deployed, and it would just pull in all those solutions and deploy the DLLs to the deployment folder. And that was basically all that was necessary.
So if you want to add one plugin, you have to deploy.
Well, basically, it won't get picked up until you restart the application. So you can just add the 2 DLLs to the folder and then restart. That would work. The thing is, we had like monthly deploys, so it wasn't really that big of a deal because we would only change plugins at those times. But you can be really flexible, but you will need to restart. That's the thing you will need to do.
So that question, not very familiar. I work a bit with .NET, but it's quite some time ago. So what happens if those DLLs, that you want to add, have dependencies to other?
That's okay. What happens if the plugins have references to other DLLs? Your solution for your plugin will basically contain all the dependencies that that plugin needs. So you would need to take the entire deployment folder of your plugin and add that to your deployment. So if that one uses external libraries, like, for instance, an API that your device supplier gave you, yeah, you would have to include that in your plugin. And that would get deployed along with it. So that's okay, that works. I think we're running out of time, aren't we? No, we still have like 2 more questions. Yes?
Why did you select that plugin mode instead of creating a separate microservice for each one of the different features, like a Lego microservice and a monolith?
Well, I explain that a little bit in the beginning. It's because microservices would really complicate our deployment. And we're using this part of the code, this core logic, in some of the services that we already had, because it was already service-oriented. And we felt that if we were already struggling with deploying like the 8 or 9 services that we had, and keeping that all working together, we didn't feel that the team was ready to move into full-on microservices, because that adds so much more complexity.
But it would have been an approach.
It could be, yeah, it could be an approach, but we were like 7 people in the team, so it's not like we needed to be able to work independently on different services. Wasn't really like that. And usually when we did a device implementation, we would go through a phase where we started the development, and then we would finish it, we did some bug fixing, and then probably we wouldn't touch it for like a few years until that supplier came with new devices. So with microservices, you're often aiming for the benefit of being able to redeploy everything separately, but we didn't really need that as well, so that's why. Right, I'm gonna wrap up. If you have more questions, just come and see me in the hallway. I don't bite, I'm not scary, and I like talking to other developers, so please come and find me. There's one more thing I want to talk about. It has nothing to do with the rest of the type, so if you don't like it, just leave. As an industry, we have a problem. Because if I look around this room, I see what I usually see when I'm standing in front of a room like this. I see a lot of white guys. And that's okay. You don't have to apologize for being a white guy. But we have blind spots. And because we are a very, very monotone industry, it means that all of our blind spots are most likely going to be the same. And you have this thing where if you're going to try and hire someone for your team, you're also psychologically going to look for a person that is like you. So if you're a team of white guys, you will probably ending up hiring another guy that is like you. Where you should actually be looking for what skills is our team missing and hire for that. And you will get a more diverse team, and everything will work way better. So what I want you all to do when you're hiring your next guy is to think about this and make a conscious choice to hire the person that adds something to your team that you don't already have. Just respect each other, you will be fine. Don't apologize for being a white guy, I am one as well. But you have to be aware of this problem. My name is Hannes, this is my Twitter handle, and at that URL you can find the slides and the code samples. Come and see me in the hallway if you have more questions, and I thank you all for sitting through this hour. Thank you.